This is Honors Algebra 2 Pre-Calculus. We're doing the last section in Algebra 2, Chapter 1, which is 1.8. We're talking about absolute values. So this chapter has us solving absolute value equations and absolute value inequalities. But before we can do that, we should sort of talk about what an absolute value is. So we're going to talk a little bit about the physical definition, like the geometric definition, and DEF apostrophe N is a mathematical abbreviation for definition. It's legit, it's not just a Hoganism. The algebraic definition, and then sort of the logical definition that you've understood most of your lives about how to use an absolute value, or at least for the last several years of your math life. So what it means geometrically to take an absolute value of a number is to find its distance from zero on a number line. So for example, let's look at the absolute value of -5 versus the absolute value of 5 on a number line, okay? So if we look at this on a number line, when we talk about the absolute value of -5, right, and actually I'll give us a little bit of space so we can see the difference of the two, right? When we talk about the absolute value, and actually let's do -5 and let's do 3 just to make the point that they're different numbers. So here's 0, 1, 2, 3, 4. There's -5, right? If we measured the distance from -5 to 0 on a number line, it would be 5 units, okay? Thus, the absolute value of -5 is a 5 because distance is what we call a scalar. It doesn't have a direction. So it doesn't matter that -5 is left of 0. It just matters that it's 5 units away. If we look at the absolute value of 3 on a number line, here's 0, 1, 2, 3, right? Again, 3 is 3 units away, so the absolute value of 3 is a 3, right? Now let's look at this algebraic definition. Algebraically, if we have a positive number inside of an absolute value, it does nothing. So, for example, the absolute value of 0, which 0 is technically neither positive or negative, but bear with me that we include it with the positives here. So if we have a non-negative value, that's the safer way to say it. So if x is non-negative, meaning 0 or positive, and we take an absolute value, it does nothing. The absolute value of 0 is 0. Now that makes a lot of sense if you think about it in the context of this first definition, because how far is 0 from itself? Well, it's 0 units away, right? The absolute value of 1 is a 1. The absolute value of 57 is a 57. If you put a positive number inside an absolute value, you just get that number back out. And that's all this says. It says if x is a positive, or let's say non-negative because we're including 0. If x is a non-negative number and you put it inside an absolute value, literally nothing happens. You put an x in, you get an x out, that's it. But if x is a negative number, right, that's what x is less than 0 says. It says x is negative. If x is a negative number, then the thing you get out is not x, because that would be negative. It's the opposite of x, right? That's what a negative means. So it's the opposite of that negative number, right? Because x was a negative number, the opposite of a negative number would come out positive. Thus, if you do the absolute value of -10, you get out the opposite of -10. Well, look, that's a positive 10. So again, and now all of this is to say that if you actually look at the logical definition, which is the thing I put at the bottom, most of you have been using absolute values for at least a couple years in math, and in your brain you probably think absolute value makes things positive. End of story. And that's great because that's basically what happens, right? So if in your brain you were like, hey, I see the absolute value of -5 and I think, yo, that's a 5, you are not wrong, okay? Now, it does get slightly more complicated if we throw some stuff inside the absolute values. Like if we, let me just give you an example. So if inside the absolute value I throw in some stuff that needs to be simplified, you would need to do that first, right? It is worth noting that the absolute value is a grouping symbol, right? So it falls under parentheses, right? So just as an example, like random, not even an example 1, just a quick idea of walking through. If I asked you what the absolute value of 8 minus 11 is, you'd have to do 8 minus 11 first and get a -3. The absolute value of -3 is a positive 3, right? If I asked you something like, what is the absolute value of 10 divided by 2 plus 4 minus a 7, right? You would basically follow all the PEMDAS rules that we've been doing, right? You would deal with, so this is a grouping symbol, right? But you can't do the stuff inside it till you deal with this 10 divided by 2. So you get this is a 5 plus 4 inside the absolute value minus a 7. You'd get that this is the absolute value of 9 minus a 7, which is just a 9 minus 7, and you get a 2, right? Again, this is not a section specifically asking you to evaluate absolute values. That's the stuff that you'll see earlier in math, but I just wanted to throw that out there that that's the way these operations work. So now we're going to go ahead and walk through what an absolute value equation looks like. We're going to talk about how you can solve it graphing in a calculator, and then we're going to talk about how you can solve it by hand. Most of these problems you're going to be able to solve by hand, but it's worth knowing how we put stuff in a calculator if we need to. So let's first talk about how we use absolute value in a calculator. So absolute value in your calculator, okay? So in your calculator, absolute value is under the math button, right, which is right here under alpha, okay? So to get to absolute value in a calculator, you press the math button, okay? You go over to number, right? So so you go over 1 to number, which says num, right? And then you'll notice the very first thing under num is number 1 is abs, right? So number 1 says abs, and that is your absolute value, right? So if, for instance, for example, if I wanted to put into my calculator the absolute value of -8, which would be weird because I think we can all agree that that's just 8. But if I wanted to put it in my calculator, the way I would do it is math number 1, which would give me abs. I'd put the -8 inside the absolute value, and I'd hit enter. So I'm going to go to math number 1. I get abs. I put a -8, and the negative is this button at the bottom. It's not the minus button. So I put a -8, and then I'd hit enter, and there you have it. It's an 8. Now, that shouldn't be rocket science, and it shouldn't be super duper exciting, and I would really hope that you're not using a calculator to find the absolute value of -8. But there are reasons to use a calculator to find the absolute value of something. So let's walk through a reason to doing that, okay? So if we want to solve an absolute value equation, right, so let's say we want to solve an absolute value equation, okay? The trick here is that absolute value is one of the few functions in mathematics that doesn't have an undo. It doesn't have an inverse function. In math, when we're solving, right, we've talked a lot about how when we do order of operations, we use PEMDAS, and when we solve, we do SADMEP. Well, the reason it's backwards of PEMDAS is because what we're doing is undo. It's like if you're typing stuff in a Google Sheet or like in Microsoft Word or whatever, and you want to undo something, the way it undoes things is it undoes the most recent action first, right? And then if you want to undo like 3 steps back, you probably have to undo the last 3 steps to get back to that other step. Well, it's the same thing here. If the last thing you did when you were doing order of operations was the S, right, because you did PEMDAS, well, then when you want to undo order of operations to solve, the first thing you have to do is start at the SA, right, like you do SADMEP, which is the reverse of PEMDAS. So when we solve an absolute value equation, what makes this tricky, right, so solving an absolute value equation is tricky because there's no undo, which is really called an inverse operation if we're being all fancy and mathy in our math class, right? There's no undo for an absolute value. Most functions in mathematics have an undo. Multiplication has division, addition has subtraction, right? Squaring has square rooting, but tricky absolute value, there is no undo. So what we have to do, right, so because that's tricky, what we have to do is essentially solve down to the absolute value and then use sort of a trick to solve, okay? So, let's think about how to talk about this. Okay, so, if I tell you, so if, let's say that I tell you that the absolute value of x equals 3. Okay, so if I tell you the absolute value of x equals 3, and I want you to give me the solutions to this, the problem is that there's no way to undo this absolute value. It's like a locked box. So what I want you to do instead is I want you to think in your brain, okay, hey, pretend that this wasn't here. Let's say you can't see the x. What number is under my hand? Now, if I'm in a classroom with you, which is always preferable to just talking to a video, but let's say I'm in a classroom with you, somebody in the class is going to either raise a hand or shout out, I don't care, either one's fine, they're going to say 3. And they're not wrong, right? Because if there was a 3 under my hand, right, if there were a 3 under my hand, this would say the absolute value of 3 is 3, which is true, right? So someone in the room is going to be like, oh, Hogan, that's a 3 under your hand. You're not wrong, totally a 3. But then someone else in the room is going to be like, yo, Hogan, that thing under your hand, it's a -3. And they're also right, because the absolute value of -3 would also come out to be 3, right? So the trick here is that this thing under my hand could either be a 3 or it could be a -3. So the answer to this statement is that x is either a 3 or x is a -3, right? And you could write plus or minus 3, and I'm going to show you why I don't choose to do that in this case when we get to harder problems, but you could also write this if you preferred as x is plus or minus 3, right? So the trick is that this number under my hand, this mystery variable, could be one of two things. The thing inside the absolute value could be equal to 3, because the absolute value of 3 is 3, or it could be equal to -3. So on page 62 of your book, they address this, right? So your book actually addresses this on page 62 by telling you that if the absolute value of x equals a, then x is either a or x is -a. Right? Like those are the two possible values for x. Sorry that my a's kind of look like 9s. So we're going to talk about how we can solve absolute value equations using that information, right? But before we do that, I'm going to take a second to actually graph this one in my calculator and show you how you could also use a calculator to find this value, okay? So the other way to solve this, other than figuring it out mentally, is you can do what we practiced not long ago when we were solving equations, and you could make the left-hand side of your equation y1, and you could make the right-hand side of your equation y2. So let's go ahead and do that. Now, we did learn just now how to type in an absolute value in my calculator. So what I'm going to type in as the y1 in my calculator is abs x, and what I'm going to type in as the y2 is just the number 3. And what you're going to find is that I'm going to get a graph that gives me, in fact, these exact two answers. So if we go to y equals, and I'm going to clear out what was in there, so see it's empty now, I went to y equals, right? And I'm going to type in math number 1 to get to abs, right? So math over to number, pick 1, absolute value of x, close the parentheses, and in my y2, I'm going to type in a 3, right? So absolute value of x and 3. So now, I'm probably zoom 6 because we're usually zoom 6, but if you're not, you could go ahead and hit zoom 6, and I'm going to go ahead and graph. And what you're going to see is that the absolute value graph is like a V, right? And then a line comes across, and you'll see that there are 2 points of intersection. So if I were to graph this over here just as a crappy version so that you can see it without me holding the calculator up, here's what's happening. I have this V that looks like this. This is my absolute value graph, absolute value of x. And then I have this line that comes across at 3, and sure enough, there's an intersection at x equals 3, and there's an intersection when x is -3, which are the same 2 answers. So you can solve absolute value equations using graphing pretty easily, but I also want you to be able to solve them by hand because you're just not always going to have a calculator. Now, I know when someone says that, they're like, but Hogan, we have cell phones nowadays. Correct. But I want you to get some AP college credit, and you will not have a calculator on the entirety of the AP exam. You will also have a lot of college courses that use non-calculator exams as a way to weed you out of a major, so you're going to have to get used to doing some math without calculators with me. So, what we're going to talk about in the next video is we're going to start solving absolute value equations. We're going to talk about how we deal with this trickiness of not having a way to undo an absolute value. So that's our next video.